Have you ever tried to calculate a limit and ended up with 0 over 0 or infinity over infinity? This is where things get really tricky and confusing in calculus, but don't worry, I'm here to assist you with this. First of all, welcome to Post Scholars channel. If you are preparing for NECO exam, WAEC exam, JAMB exam, or any other college exam, then this video is for you. The title of this video is Limits of a Function Undefined at a Point, right? So in this video, you get to understand what happens to the limit of a function when it's undefined at a point. We have two questions we are going to solve, right? Here's the first question, which I've duplicated here. So let's solve this together. Now the question says, find the limits of this function, right, as x approaches 5 or as x gets closer and closer to 5. But if you observe this function very well, you will see that the value of this function, right, when x is exactly 5, will be given as 0 over 0. How do I know that? This is 5. Substitute 5 into this. You have 5 times 5, which gives what? 25, right? 25. Then 25 minus 25 gives what? 0. Now similarly for the denominator, substitute x as 5, right? It becomes 5 minus what? 5. And this also gives what? 0. But 0 over 0 is in an indeterminate form. It simply means the value, this function is undefined at x equal 5. It means there's no answer for this function. There's no value for this function when x is equal to 5, right? But we are not interested in x is equal to 5. All we are interested in is the value of this function as x gets closer and closer to 5. That's what we are interested in, right? So the next thing to do is to simplify this function, right? How do we do that? If you observe this numerator, you will see that it's looking like a difference of 2 square, right? Remember difference of 2 square. Difference of 2 square says if you have x square minus y square, it can also be written as what? X plus y and x minus y. Similarly, if you have x square minus 64, right, it becomes what? X minus 8, right, and x plus 8. So that's a rule guiding difference of 2 squares. And here we have it here, 2 squares, right? So let's continue. Then we have limits of the function as x tends to what? 5. Like I said, this is a difference of 2 squares. So you tell me now, what will be the other form for this difference of 2 squares? Something like this. What will it be? You can say it now. It's supposed to be x minus 5, right, and x plus 5. Then the denominator remains x minus 5. Now we can say x minus 5 cancels x minus 5. And what's left? We are left with what? X plus 5. So let's write that. So we have limits of the function x minus 5, x plus 5 rather, as x tends to what? 5. Now the next thing to do is to substitute the value of 5, the value of x, which is 5, into this function. So this x takes the value of what? 5. So we have 5 plus 5, and the answer gives what? 10. This is the final answer. So it simply means that the value of this function as x gets closer and closer to 5 is equal to what? 10. But remember, at exactly 5, the function is what? Indeterminate or undefined. But we are not interested in that. We are only interested in the case of the fact that when it's getting closer and closer to 5. So the final answer for question 1 is 10. So let's solve question 2. Question 2 says, what is the limit of this function, right, as x approaches what? Infinity. This is the symbol for infinity. You start by substituting the value of x into this function. When you do that, you observe that the numerator, in the numerator you have infinity, and in the denominator also you have what? infinity, right? That's when you substitute x equal infinity into this function. But infinity over infinity is an indeterminate form, or is an indeterminate form, which simply means that this function is undefined when x is equal to what? Infinity. And like I said, in limit, we are not interested in the exact points. We are only interested in as it gets closer and closer to infinity. Now, this kind of question will make you remember a particular rule, right? And the rule says the limit of the function 1 over x as x tends to infinity is equal to 0. You can prove this yourself by saying 1 over, take notes, x tends to infinity. Let's assume the infinity to be 999, right? 999, yes, 999. Now you can see this is actually 9,999,999,999. Now if you do this division, you will see that you will get a number that is exactly what? 0. You can try it. So we are going to apply this rule on this function. So to do that, we have limit as x tends to infinity. Now what we can do in this case now is to simplify this, rewrite this in a particular form, right? That will be convenient for the limit. So to do that, what I can do is first of all is to factorize x raised to power 3 out. And when I do that, I'll have x raised to power 3 into brackets. I'm not breaking the mathematical rule, right? 3. So that when I say x raised to power 3 times 3, I still get my 3x raised to power 3, right? Then plus the next term, right? Instead of 2x squared, I can write 2 over what? X, right? Now confirm your answer. You see x cancel what? X. Then you have x squared left. X squared times 2 gives you what? 2x squared. So we are not breaking any rule. Now this term, which is x, becomes plus 1 over what? X squared. You can confirm that you have not broken the rule. X squared cancel x squared divided by s cube. You are left with what? X. So we didn't break any rule. Then this 1 can be written as plus 1 over what? S cube. Then you close the bracket. What this is simply saying is that when you use x3 to expand or to open the bracket, you still get the same thing here. So we didn't break any principle. What we just did was that we factored out x raised to power 3, right? Then you do the same thing for the denominator. For the denominator, you will have something like this. Similarly, you factor out the highest power, which is x raised to power 3. And when you factor out x raised to power 3, right, what will be left to be 1 plus, you can confirm it, 2 over x squared, right, plus 5 over x raised to power what? 3. Similarly, when you use this term, right, to expand these other terms, you have x raised to power 3 plus 2x squared plus x. So we didn't break any principle, right? We only simplified this, right? Now looking at this, you observe that I can easily say x raised to power 3 cancels x raised to power 3 without breaking any principle. Then what's left is limit as x tends to infinity, right? What's left to be 3 plus 2 over x plus 1 over x squared plus 1 over x cubed. Then over denominator we have 1 plus 2 over x squared plus 5 over x raised to power what? 3, right? You can see we have reduced this. We have reduced this to this. Then what comes to your mind now? You can now use this rule, right? Use this rule on each of these terms, right? To do that, remember we have confirmed that the limit of 1 over x as x tends to infinity is what? 0. So let's apply that rule. Applying the rule, you have for the first term, you have limit as x tends to infinity 3 plus limit as x tends to infinity of the function 2 over x, we are working with the numerator now, plus limit as x tends to infinity of the function 1 over x squared, then plus limit as x tends to infinity of the function 1 over x cubed. Now we are done with the numerator. Now let's work with the denominator. So for denominator, we have limit as x tends to infinity of the function 1, which is a constant, plus limit as x tends to infinity of the function 2 over x squared, plus limit as x tends to infinity of the function 5 over x squared. So it's easy for us to work with now. So all this will be equal to what's the limit of a constant? The limit of a constant is still the constant, right? So this becomes 3, right? Plus, remember we have agreed that the limit of 1 over x, right, as s tends to infinity is what? 0. Now you will see that there is a 1 here. So 1 over x becomes what? 0. Then 0 times 2 also becomes what? 0. So everything here becomes 0, right? Then plus, similarly also, the limit as s tends to infinity of 1 over s squared is still what? 0, right? Then lastly, this term also becomes what? 0. Then for the denominator, the limit of a constant, so this is a constant, is still what? 1. Still the constant. So write 1, then plus, using this rule, right? This rule, limit as x tends to infinity of the function 1 over x. This 1 can be 2, 3. It must be a constant. It can be that 1, 2, 3, 4, 5, 6, or any other number. But the limit becomes what? 0. So similarly, everything here becomes what? 0. Then plus this term also, this last term here becomes what? 0. So when we simplify the numerator, we have 3 plus 0 plus 0 plus 0, and that gives 3 over 1. And 3 divided by 1 is equal to what? 3. That's the final answer. So what this function is saying is that instead of us to write infinity over infinity, you can see it is infinity over infinity when we are saying that x must be equal to what? Infinity. But when we are considering the fact that x is approaching infinity, then the answer is going to be what? 3, which is this, right? So I need you to understand the differences. There's a difference between x equal infinity, right, and when x approaches what? Infinity. So the final answer for this limit is equal to 3. So we have come to the end of this video. If you have any comment or any question, you can drop it in the comments. God bless you. I wish to see you in my next video. Bye.